Okay, we're back in week 11. This is the second video. We're going to continue graphing lines. This is in slope-intercept form. It just means that this is the slope and this is the y-intercept. But in this class in week 11, they don't make you graph by slope and intercept. They make you graph by using like an old school chart, which is totally fine. There's many ways to skin the cat. So we're just going to find 2 points that lay on this line. Always try to put 0 in for your x, and then try to keep around 0 to maybe 1 or -1. I try to stay in the positive integers, so I'll pick 1. Okay, so here we go. I'm going to pop in, we want to know what y is. So y is equal to 2 times the x value that we're giving it, substituting it in, minus 5. Well, 2 times 0 we know is 0, and 0 minus 5 is -5. So 0, -5 is 1 point. And then let's put a 1 in there. So y is equal to 2 times 1 minus 5. So y equals 2 minus 5. So y is equal to -3. So basically, I think about this as if I feed the dog 1 bone, out comes -3 bones. If I feed the dog 0 bones, out comes -5 bones. So I think about that as like x is your input, y is your output. And so let's go ahead and graph these points. So I got my x and my y. If I start at the origin and I move nowhere on my x, but I go down to -5, 1, 2, 3, 4, on my y, that's that point there. And then 1, -3. So I'm going to move 1 on the x and down 1, 2, -3 on the y. So my line is going to look something like this. And I always put arrows on the end of my line to show that it continues into infinity. Forever and ever, it's hanging out with Buzz Lightyear. Okay, let's try another one. So I want you to pause the video and graph the line y equals -x plus 6. So if you're back, hopefully you made a chart. I'm hoping you put 0 in for x and maybe put 1 in for x, right? So those are tried and true x values, right? They're really close to one's at the origin and one is next to the origin. So y equals negative, we're going to put a 0 in for x. Okay. So what is negative times 0? Well, it's really nothing. So y is equal to 6. Let's try putting a 1. Y equals whatever negative sign times 1 plus 6. Well, that becomes -1 plus 6, and y is equal to 5. All right, so I got a couple points out of the infinite choices at the buffet of choices of coordinates. So I just need 2 just to graph it. So I'm going to start at the origin. This says move 0 on the x, but up to 6 on the y. 2, 3, 4, 5, 6. And then this says start at the origin, move over 1 on the x and up to 5 on the y. So I know the recording, these like coordinate plane looks kind of very light and hard to see. So I did make an announcement and I probably sent out an email that you should download. This is like printable graph paper. So if you look in the announcements in your email, I sent a link to where you can get free printable graph paper, or you can buy some at like your local Target, Walmart, or dollar store has it. Okay, let's look at, ooh, we're gonna crank it up a notch. Now we're gonna start putting a little fraction in it, a fractional slope. And that's okay, because I'm gonna show you a trick so you don't have to be fearful of these. Okay, so here is the trick. We'll make our chart. Always put 0 in for x. That's gonna actually zero out that whole thing, which is gonna be kind of nice. But when you want to be thoughtful about what you're going to put in for x now, okay? So here's my hint. Look at the denominator of the fraction, and that's what you want to put in for x, or any multiple. So I would put, in this particular case, I would put a 4 or an 8 or a 12 or a 16. Any multiple of 4 will work. And I'll show you why that's so nice. So let's start off by putting 0 in for x. So y, which is what we're looking for, is equivalent to 3/4 times 0 minus 1. Well, anything times 0 goes away. So y is equal to -1. Boom, that was easy. Okay, let's put a 4 in for x. Y equals 3/4. We're going to substitute in 4 minus 1. Well, what I love about this is these 4's cancel, and y equals 3 minus 1, so y equals 2. So see how beautiful that was? If you want to see why they cancel, let me show you kind of in slow motion over here. So over in the corner, let's do this multiplication. 3/4 times 4 over 1, which is that 4. 3 times 4 is 12. 4 times 1 is 4. 12 divided by 4 is 3. 3 minus 1 is 2. All right, let's graph this. This says move 0 on the x, but down to -1 on the y. This says move to 4 on the x, 1, 2, 3, 4, and go up 2 on the y. So we have 0, -1, and 4, 2. Okay. As you're getting started with graphing, I'm going to bring back that piece of paper here. If you've never graphed before, I would just have like a piece of printable graph paper if you got some from the dollar store or Walmart, Target, or something like that. Amazon's got it, I'm sure. Should be a couple bucks for a pack. You can make your own, XY chart. Always put your little 0 there, right? And that way you can kind of cleanly see this. So like, if I want to graph the point, let's say 2, -4, right? I would start at the origin. I'd move on the x-axis to 2 and down to 1, 2, 3, -4. That would be the point 2, -4 right here. If you need to, while you're starting off, you could go 1, 2, 3, 4, 5, 6. You can come up 1, 2, 3, 4. This way you're going to go, that's 0, so that's -1, -2, -3, -4, and down -1, -2, -3, -4, -5. So if you need to number these, there's no shame in that. Number it. It just takes a little extra second or two. That way you know you can move on the x to 2 and down to -4 on the y instead of counting. I just count, but if you want to put the numbers on, that's totally fine. Okay, let's move to another type of problem. All right, we have another fractional, they call it a fractional slope here. So what you're going to do is just always put 0 in for x and then look carefully at the denominator. You want to put a 2 or a 4 or a 6 and 8, some multiple of 2 in for x. So I'm just going to use 2. Okay, y equals, and go ahead and pause the video and come back and see how you did. Okay, a half times 0 is just 0, so y is equal to -2. That's the beautiful thing about zeros. Now let's put 2 in for x. So you can think about this a couple different ways. A half of 2 is 1, right? And 1 minus 2 is -1. You can cancel that out and do 1 minus 2 is -1. You could do it in slow motion off in the corner, right? 1/2 times 2 is 2 over 2, which is 1, minus 2 is -1. So anyway, you want to slice and dice that. The reason that you want to use a multiple of 2 is let's try another multiple of 2. Let's try a 4. Okay, so you don't have to do this, but I just want to sort of show you why using the multiples works. All right, so a half of 4 we know is 2. 2 minus 2 is 0. Or off in the shadows, 1/2 times 4 over 1 is kind of clean, right? 1 times 4 is 4. 2 times 1 is 2. 4 divided by 2 is 2. 2 minus 2 is 0. Okay, so kind of nice multiples of whatever that denominator is always going to give you a nice clean answer. So 0, -2 is going to be here, and 2, -1 is going to be here. So I can connect those dots. I'm just graphing 2 of these. Right? I don't need to graph all 3. In fact, Alex isn't going to let you on that program. But here's 4, 0. 1, 2, 3, 4, 0. So I technically can throw my third point on there if I want to. But just remember, Alex is only going to let you graph 2 at a time. Okay, this is an equation given in standard form. Standard form looks a little different. We've been looking at y equals mx plus b. That's just one way of looking at a line. Another way is ax plus by equals c, which is what they call standard form. We're not going to get too involved in that this week. We're just going to stick with making our charts, putting numbers in for X. Okay, so I'm going to put a 0 and maybe a 1 in here. Those are my favorite X values to substitute in. So we're going to put a 0 in for X. So 0 plus what number equals 2? Well, we know it's 2, right? Because that kind of goes away. How about a 1? 1 plus what number equals 2? Well, we know it's going to be a 1. If you're not sure, just subtract the 1 on both sides and you'll get that 1 there. So we're going to graph 0, 2, so 0, 1, 2, and 1, 1. Come over 1 and up 1. So that one was pretty easy and quick. You didn't have to use any algebra if you just wanted to say to yourself, what two numbers add to 2? Well, 0 and 2, or 2 and 0, or 1 and 1. So lots of possibilities. You could go -2 and 0. You could go 0 and -2. Actually, it should be +2 and 0, which I guess I already have there. And 0 and -2 would not give us 2. How about 0 and, well, I guess we already have 0 and 2. And 1 and 1. I'm not going to get fancy here. Anyways, you can sort of brainstorm what two numbers would you add together and equal to, and that way you can come up with your two sets of coordinates if you want. Or you can go old school like we did. Okay, let's take a look here. Graphing the line x plus y equals -4. Okay, give this video a pause. Come up with two numbers that add to -4. Go old school if you need to. I'm going to go old school. So come back and see me in a minute. Okay, so if you're back, if I put a 0 in for x, 0 plus, I know it's going to be -4. But if you want to do it old school, which I like also, it never fails me. 0 plus y equals -4. Well, y is equal to -4. Let's put a 1 in for x. 1 plus what number equals -4? Well, if you're not sure, you can subtract 1, right? And y is equal to -5. Because 1 plus -5 gives you -4. All right, let's graph these. 0 and -4. So 0 down 1, 2, 3, 4. And 1 over 1 down 1, 2, 3, 4, -5. Your line's going to look just like that. Cute little line here. Okay, what else is lurking in here? Let's take a peek here. We're going to get into vertical and horizontal lines. Okay, these are my favorite of all. Okay, first it says graph the line x equals 5. Well, notice there's no y here. So you kind of can't make an XY chart. I mean, you could if you want to, but just know that the x value is always going to be equal to 5. So 5, 5, 5, 5. And then you can pick any y's that you want to. I'll show you what I mean by that. So first of all, what is vertical? A vertical line means it's going to look like that. Okay, that's vertical. And if this could talk, it would say to you, I cross the x axis at 5. Okay, so go find the x-axis, go find 5. 1, 2, 3, 4, 5. So that's where it intersects with that. And it's got to be a vertical line. So you're just going to draw yourself a vertical line. Now on Alex, you'll have to pick another point, right? And it could be any and all of these points. Alex is going to probably limit you to 2. So you just need to grab a second point. So like this is 5, 0. This is 5, 1, 5, 2, 5, 1, 0, 1, 2, 3. This is, let me separate these here. This is 5, -1 right here. This is 5, -2. So 5, -1, 5, -2. This is 5, -1, 2, -3 right there. So what do you notice? Every single x value is a 5. So if this thing could talk, it's going to say, hey, I'm never going to cross this y-axis here. I'm just doing my thing, being a vertical line, crossing it where x is equal to 5. Let's try another one. Graphing a vertical line, x equals -2. So we're going to go over to where x-axis is -2. And we're going to graph a vertical line. Now, on Alex, it's going to say graph a vertical or horizontal line. So you're going to have to decide, is it a vertical line or is it a horizontal line? Vertical lines are always x equal. Horizontal lines are always y equal. Okay. So when you see x equals -2, just know you're going to go the x-axis to -2, and you're going to plant yourself right there, and then just pick another point on that vertical line. Doesn't matter. Because what's happening here is x is always -2. No matter how you slice and dice this thing, x is -2 all day, every day. So it could be -2, 0. It could be -2, 2. It could be -2, 4. It could be -2, -1, right? But what's the common theme? X is always equal to -2. It never leaves, it never strays from that vertical line of -2 on the x-axis. Let's try some horizontal lines. So horizontal lines are always in the form y equals. Let's take a look at one of those. Graphing a horizontal line. Okay, y equals 3. So you're going to go to your y-axis. You're going to come up to 1, 2, 3. You're going to plant it. Then you're going to pick another point somewhere that's going to make that a horizontal line. Okay, so horizontal line. I remember horizontal because if you think about horizontal, the sun comes up on the horizon, right? There's your horizontal line there. So if you have to make a chart of values here, just know y is always going to be 3. All day, every day, y is equal to 3. So if you were to try to like pinpoint what these points are here, right? This one here would be -1, 3. This one here would be 0, 3. 1, 3. 2, 3. Okay, what's the common theme? Y is always equal to 3 on a horizontal line. So hopefully this is making some sense. Let's try another horizontal line. I cross y at -8. Well, here's x, here's y. So we're going to come down 1, 2, 3, 4, 5, 6, 7, 8. That's y equals -8, but we have to make a line that goes through it. So just pick another random point and draw yourself a horizontal line. Again, we could give names to all of these points here if we wanted to. Just know that y is always equal to what? -8 every day, all day. That's all it's doing. So x might be 0 and -8. We might have 2 and -8. We might have -2 and -8. I mean, just for giggles, we could come down here, and this would be 1, 2, 3, 4, 5, -8. Okay, what's the theme? It's always y is -8. So don't be scared of the vertical and horizontal lines. You can do it. Okay, we're going to get into crossing intercepts or graphing an intercept. So this is actually titled Finding an X and Y Intercept of a Line Given the Equation. Okay, the equation is right here. Let me highlight that. Let's highlight the equation. And then I made myself a little note that I wanted to just remind everybody that it's kind of weird, but in Alex, they don't want you to put your answer in coordinate form, which I don't agree with. So they're going to ask you for your x-intercept, and then they're going to ask you for your y-intercept. Okay. The reason I don't agree with this is because when you are graphing, you're graphing coordinates. Okay, but this time they're not asking you to graph, so they're just asking you to identify the intercept. Okay, what is an intercept? Well, let's take a peek. I'm going to break out my handy dandy printable graph paper, and I'm just going to make like a little. I'm just going to kind of go off script here for a minute. Okay, so here's my y, here's my x, and I'm going to draw a I'm going to draw a line through this. Okay, what is an intercept? It's where a line intersects with the X and Y axis. Okay, so intercept is just where the line intersects or slams into the X and the Y axis. So here's a line right here. If you want to know the y-intercept, well, where does this line slam into the y-axis? Right here. And that point is 0, 2. This is the y-intercept. Okay, this point here is where it slams into the x-axis. This is the x-intercept, or where it slams into or intersects with the x-axis. This is -1, -2, -3, 0. Okay, special note about intercepts. If you're looking for an x-intercept, your y value must be 0. If you're looking for a y-intercept, your x value must be 0. Okay, so we're going to write that out on the next piece of paper here. So this is going to hold true every single time. So when they ask you for these special points that are called intercepts, you need to let x equals 0 to find your y-intercept, and let y equals 0 to find your x-intercept. So let's write that down here. Intercept, to find the x-intercept, you're going to let y equals 0. To find your y-intercept, you're going to let x equals 0. So it's kind of the opposite. If you want to know where your line intersects with the x-axis, let y be equal to 0. If you want to know where your line intersects or intercepts with the y-axis, you're going to let x equal 0. So we're going to go back to this equation here. X plus 2y equals 8. Okay, so we're going to draw a chart. This time I'm going to put a 0 here and a 0 here. So if I put a 0 in for y, right, if I let y be equal to 0, this is going to be my x-intercept. If I let x be equal to 0, this is going to help me find my y-intercept. Okay, so let's go for it. We've got this crazy little equation, x plus 2y equals 8. Let's put a 0 in for x and see if we can get it to give birth to the y-intercept. I'm going to put a 0 in for x plus 2y equals 8. Okay, I can just subtract 0 from both sides. 2y equals 8. And then I want to know what y is, so I just divide each side by 2, and y is equal to 4. So my y-intercept is just 4. They don't want you to give it in like the professional format of 0, 4, right? They don't want that. They just want you to say 4. But if we wanted to sketch this out, 0, 4 would be 0, 1, 2, 3, 4. That's the y-intercept. Okay, let's go find the x-intercept. To find the x-intercept, we need to let y be equal to 0. So we're going to go again with this equation. X plus 2, but this time we're going to put a 0 in for y equals 8. X plus 2 times 0 is 0 equals 8. So x just equals 8. So 1, 2, 3, 4, 5, 6, 7, 8. That is that point right there at 8, 0. But that's a special point called the x-intercept. So on Alex, they just want you to put 8 there. Okay, so don't put it in coordinate form, which is 8, 0. They're just being picky about that. I don't want you to get frustrated because it's frustrating sometimes. Let's try another example of finding intercepts of a line. Okay, finding x and y intercepts. We've got a new line, 3x minus 6y equals -12. Let's make our chart. So we're going to let y equals 0 to find x-intercept. We're going to let x equals 0 to find y intercept. These are just two special places. If this line happens to cross the X and the Y axis, we're going to find those points. Okay, so you're going to solve this equation kind of twice. So we're going to put a 0 in for X. Let's go find that Y-intercept first. So I'm going to put a 0 in for X. So 3 times 0 minus 6Y equals negative 12. Anything times 0 just cancels, so negative 6Y equals negative 12. We want to know what Y is, so divide each side by negative 6. So Y is equal to 2. So your Y-intercept is just 2. They don't want 0, 2. Like if we were to sketch this out, I'm probably overdoing it, but I just want to make sure that we don't get angry with ourselves or Alex. 0, 2 is right here, right? But they just want the 2. Okay, let's solve this again, but let's let Y be equal to 0. So we're going to do 3x minus 6 times 0 equals negative 12. Negative 6 times 0 cancels out, so 3x equals negative 12. Divide by 3. So you got to have some algebraic skills there. X is negative 4. So x-intercept is negative 4. If we were to graph this, we'd come over 1, 2, 3, go to negative 4, don't go anywhere on the y, and we'd have a line that looks like that. So when they ask for specific places, those intercepts, you got to use these zeros here. Okay. What is this? This is your y-intercept, and this is your x-intercept. Okay, let's just take a little practice, but I have faith we got this. All right, we're going to end this video with two problems that are pretty, hopefully simple. This time they're giving us a graph, and they're asking us to create a graph who crosses the x-axis at 1 and the y-axis at 2. So x crosses at 1, y crosses at negative 4. So they're giving us the intercepts. So before, we had to go flush out those intercepts, right? We had to go and find them. This time they're giving them to us. So we're just going to use that information. So we're going to go to x, whereas x1 is right here. We're going to go to y. Y is negative 4 at 1, 2, 3, negative 4. If I kind of zoom in, you can see that my graph paper does have lines. It just kind of printed out kind of light. So I actually am going to just connect these. Boom. We have graphed a line whose x-intercept is 1 and whose y-intercept is negative 4. One more. Graphing a line whose intercept is 3 and whose y-intercept is 5. All right, we got this. So we want to find where x is going to cross at 3, y is going to cross at 5. So here's x, here's y. X is going to cross at 1, 2, 3. Y is going to cross at 1, 2, 3, 4, 5. I love these. We could do these all day long. Like no algebra required, no heavy thinking required. All right, so that's it for this video. I'll see you in a few minutes in video number 3. Bye.